In this video, we're going to extend our conversation about stoichiometry to include a new concept that involves something called limiting reactants. Limiting reactants. So this is officially new content, so anytime we're taking notes for a video with new content, in the top right corner I will make the note of the new vocabulary words that you will need to know from this video. And you need to take these vocabulary words and create flashcards for them on cram.com. So the three vocabulary word flashcards for this video are limiting reactant, excess reactant, and reagent. So over the course of the video, I will go over what each one of those means, and then you'll need to go to cram.com and make your flashcards for each one of those. So when we're talking about a limiting reactant, it's very easy to think of it conceptually from a non-chemistry standpoint first. So let's say you wanted to make a grilled cheese. Okay? So to make a grilled cheese, you need two ingredients. You need bread, which we have here. You need cheese, which we have here. You put together, and assuming you have a stove or whatever, you can turn into a nice, delicious grilled cheese over on the right. Well, let's represent this process as a chemical equation. So as we can see in the picture, it takes two slices of bread plus one slice of cheese to make one grilled cheese. So this is kind of like a chemical equation. And we know in chemical equations, the big numbers in front of the molecules, the coefficients, represent the number of moles that are needed for the reaction to occur. But let's just stay away from the chemistry for now still. Let's say, for example, you went into your fridge and you found 4 slices of bread and you found 4 slices of cheese. Okay? How many grilled cheeses could you make with those materials? Well, if you have 4 slices of bread, but it takes 2 slices of bread to make one sandwich, you could make only 2 grilled cheeses because you need 2 slices of bread for each one. With the 4 slices of cheese, you could make 4 grilled cheeses. So how many can you make with the materials that are given to you? You can only make a maximum of 2 grilled cheeses. So out of the reactants that you started with, bread and cheese, okay, one of them is limiting the amount of product, grilled cheeses in this case, that you can make. What is that limiting material, the limiting reactant? In this case, it's the bread. So the bread is our limiting reactant. And so how would we define it? It's the reactant that limits the amount of product, amount AMT, of product that can be made. Another way of thinking of that, okay, I'm just going to add to this definition down here, is it's the reactant that gets used up. So all of the bread got used up. We had to use all 4 slices in this case. However, we did not use all the cheese. How much cheese did we use? Since we only made 2 sandwiches, we only used 2 slices of cheese. So we have leftover cheese. So in this case, the cheese is our excess reactant. What is an excess reactant? Well, it's the reactant that is left over at the end of the reaction. You will have some leftover cheese, in this case 2 slices, left over. So we've just talked about what a limiting reactant is and what an excess reactant is. You want to really think of this conceptually. Limiting is what gets all used up, and the excess is what you have left over. Now, if you have the same amount of both, does that automatically mean that they're both going to get used up? No, we saw here that didn't make sense because it depended on the coefficients. So let's apply that to chemistry now. How does this apply to atoms and molecules? So now we're dealing with an actual reaction where we take 2 moles of hydrogen to react with 1 mole of oxygen to make 2 moles of water. So how do we apply this knowledge of a limiting reactant? Well, let's say we have a question that asks this. If 10 grams of hydrogen reacts with 10 grams of oxygen, how many grams of water will be produced? So we've done problems like this in the past. However, in the past it's said something like, if 10 grams of hydrogen reacts with excess oxygen, remember we said that means you have so much that it doesn't matter? Well, we're not saying that anymore. We're saying that it does matter how much we have, okay? So anytime, a thing to note, if you're given the masses / amounts of both reactants, you need to figure out the limiting. You have to determine what is the limiting reactant, because right now we don't know. Because remember, it doesn't depend on the mass in chemistry, it depends on the number of moles. So the process that you do here is you set up two quick stoichiometry problems, and this is why our stoichiometry skills need to be really solid. So you start with your first reactant, 10 grams of H2. And what we want to do is convert it to one of the products. In this case, the only product is water. So we want to convert to moles of product. So how am I going to do that? Well, 10 grams of hydrogen, according to the periodic table, the mass of hydrogen is 2 grams per 1 mole. And now I want to convert to moles of product, so moles of water here. So I'm going to need a mole ratio. So it's 2 moles of hydrogen from the equation makes 2 moles of H2O. Okay, so if I go ahead and set that up, my moles of hydrogen cancel, grams of hydrogen cancel. I'm left with essentially 10 times 2 over 4, which is essentially just going to give me 5 moles H2O. So what is this telling me? This is telling me that if all of the grams of hydrogen react, all 10 grams, I could make 5 moles of H2O. Okay? But is that the actual total amount of water that I can make? Well, we don't actually know for sure, because we have to first do the same calculation now with our other reactant, which in this case is the grams of oxygen. So if I have 10 grams of oxygen, and if we say it all reacted, then let's figure out how many moles of water I would make then. So from the periodic table, oxygen is 32 grams, 1 mole of O2. Then the ratio here is a 1 mole of oxygen for 2 moles of H2O. So if I go ahead and complete that setup, I'm going to get 10 times 2 over 32, so about 20 divided by 32, which is equal to about 0.625 moles of H2O. Okay, so what does this information mean? Pause and think. This is saying, the first equation here, if all 10 grams of hydrogen react, I will make 5 moles of water. And down here in the second equation is if all 10 grams of oxygen react, I'll only make 0.625 moles of water. So this is like our bread and cheese analogy. In this case, all of the oxygen is going to get used up to make 0.625 moles of water. So I don't have any more oxygen to keep making up to 5 moles. So this is the maximum amount of product that can be made. So if this is the maximum amount of product, the reactant that gave us that amount of product, in this case oxygen, must be the limiting reactant. This is like the bread in our first analogy. All of the bread got used up to make those grilled cheese sandwiches before the cheese got used up. In this case, all the oxygen got used up to make water before all the hydrogen got used up. So therefore, by definition, our hydrogen, the 10 grams of hydrogen, is our excess reactant. There will be leftover hydrogen at the end. And we'll practice problems with how to calculate the amount of excess reactant and whatnot. But for now, what you really need to think about is conceptually, what does it mean if a compound is limiting or in excess, and how to figure it out on a problem like this. However, what the AP curriculum likes to test a lot more are things called particle diagrams. Okay? Particle diagrams. Particle diagrams, also called molecular models, basically show what is happening with the atoms and molecules if we zoomed in on them and looked at them in 3 dimensions. So here we have our chemical equation that we've been dealing with. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. What would that actually look like if the molecules were reacting? Well, we can see below here, we have 2 black dots representing each one of the black dots. One black dot is 1 hydrogen. So here, since we have 1, 2, that's our subscript. This is 1 molecule of hydrogen. And then the big 2, our coefficient, is the number of moles, which in this case there's 1, there's 2 moles. Here we can see that we just have 1 mole of oxygen. Why are there 2 red spheres? Because the subscript of 2 indicates I have 2 atoms of oxygen bonded together. And in water, I have a hydrogen, another hydrogen, 2 hydrogens bonded to 1 atom of oxygen, this invisible subscript 1. And there's 2 of these guys here because the coefficient is 2. So what we need to be able to do is draw diagrams like this, manipulate them, and answer questions about them using our knowledge of stoichiometry. So, for example, let's say 6 moles of oxygen gas react with 8 moles of hydrogen gas. Draw a molecular model and identify the limiting and excess reagent. Oh, here's a vocab word, reagent. The word reagent just means reactant. It's another word for reactant. But that is the 3rd flashcard you need to make for this video. So, first thing, let's turn this into an equation. Oxygen gas, O2, hydrogen gas, H2. What's it going to make? Well, we've been practicing with this equation. It's going to make water. Now we need this equation to be balanced. Well, we've been playing around with this equation all day, but there it is if it's balanced. So now let's draw a molecular model for this. Okay, so first I have 6 moles of oxygen gas. So I need to draw 6 moles of oxygen gas. So I need 1 atom of oxygen bonded to another atom of oxygen. And then I need 6 of those. So I'm going to cheat because I'm on the computer, and I'm just going to copy paste 2, 3, 4, 5, and 6. And now I need 8 moles of hydrogen gas. So I'm going to draw slightly smaller, oops, I'll use a different color here, molecules of hydrogen, okay? And I need 8 of them. So I'm going to do the same thing. Let's copy paste. So I've made 8 moles of hydrogen gas. Now I need to make my moles of water. Okay, so here's where we have to think conceptually if these things are going to get reacted. What is going to be my excess and what is going to be my limiting reagent? Well, in water, I need 2 hydrogens for every 1 oxygen. So essentially, the hydrogens are going to get used up twice as fast. So if I make 1 molecule of water, it's going to take 1 hydrogen and, 1 oxygen and 2 hydrogens, which I'll draw like this. So what did that essentially get rid of? It got rid of 1 of these and 2 of these. Okay? So then if I do that again, if I draw another molecule of water, okay, and they won't all look exactly the same because my art skills are not perfect. Now what's that going to get rid of? I'm going to get rid of another atom of oxygen and another 2 atoms of hydrogen. So we can see if we keep doing this, okay, over and over again, you might start to see the pattern about how many more I can make. I'm going to be able to make a maximum of 8 molecules of water. So if we drew all those, we'll draw them all in here real quick. Boom, 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 boom. Just make them quick here. Boom, boom. Let's think about what we're left with. So I have, it looks like 8 waters. So I have 8 red circles. So 1, 2 have been crossed out. 3, 4, 5, 6, 7, 8. And 16 total black dots. 1, 2, 3, 4 have already been canceled. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can see what is our limiting reactant. Well, it's pretty clear from here what gets used up all the way first. In this case, it's our hydrogen. Our hydrogen is limiting. All of it got used up before, it was the first reactant that all got used up. And on the other hand, our oxygen is in excess because there's still some of it left over after one of the reactants got used up. How much excess? 4 atoms of oxygen, shown here as 2 molecules of O2. So if we were to draw a really accurate picture, what we would need to draw is still have these 2 atoms, these molecules of oxygen over on the product side. And we know that is true because of something called the conservation of mass or matter, which we learned about when we balanced equations. So the total atoms we start with have to be equal to the total atoms we end with, even if they're in a different orientation. So we'll play around with diagrams like this in practice. What you need to feel comfortable with is identifying the limiting or excess reagent or reactant from them, from diagrams like this, knowing what limiting, excess, and reagent mean, and also if you're given an actual stoichiometry problem, how to identify the limiting and excess reactant by doing the math. So we'll get practice that with in class. Otherwise, that is it for limiting reactants.